presentation, I would like to ask Dr. Khoirul Anwar from Indonesia to deliver his presentation about fast smart disaster recovery network using 5G, advanced and 6G mobile base station with physical layer, artificial and quantum machine learning. Dr. Khoirul, the floor is yours.
Thank you very much, Ms. Woro, for very short and brief introduction to me. And good afternoon, everybody. And Assalamualaikum warahmatullahi wabarakatuh. I am Khoirul Anwar from Telkom University in Indonesia. This is joint work with our colleagues, Dr. Gelar Budiman and also Dr. Maryopi, and also with the help of Dr. Aswin for the regulation aspect. The title of my presentation is Fast and Smart Disaster Recovery Networks using 5G Advanced and 6G Mobile Base Station with Physical Layer, Artificial Intelligence, and also Quantum Machine Learning. So this is actually a very challenging task. That's why I would like to invite everybody to help us, especially if you are having very advanced facilities such as the quantum computer, for example, so that we can make the experiment using the proposed algorithm. But we are also welcome to any algorithm from you that we can implement to welcome the 5G Advanced in 2025 and also the 6G in 2030. Okay, so basically this is our work, the progress or the advance of our work in 2022, because we have just completed this project with the support from the ASEAN IVO with the title of the Patriot Net we developed for the disaster, but for that product we developed using 5G networks. Yeah, since 5G network has been completed in the world and in many countries, so we are trying to extend into the 5G Advanced, of which the artificial intelligence will be the processing for the signal processor for the 5G Advanced, and also the 6G with the quantum cryptography. So when we talk about another motivation why we are trying to use the disaster is that usually after the disaster, telecommunication network cannot be recovered soon, and we are also suffering from difficulties of covering large areas. And then usually the rescue team and mobile base station are suffering from difficulties in finding the victims, although the victim mobile phone are active but is out of the network. So in the previous project, or we call the Patriot Net phase 1, we completed the experiment also using the UAV or the drone. And then currently with this project, we are trying to extend to the 5G Advanced and 6G. So this is also to welcome the next generation of the telecommunications. The target of this project will be first, we continue the development of Patriot Net with the new technologies, and then we also planning to have the minimum 3 conference papers, and then 2 patents, and then 3 international journal, and also we are proposing to the standard body, especially for the Asia Pacific Wireless Group. And we are trying to repeat our success in the past, in the last year, that we submitted to Asia Pacific Wireless Group, and then it is accepted in the Asia Pacific organization. Okay, let's me repeat in brief about our last year experiment, that we have successfully made the experiment for the finding the victim and also give communication to the victims after the disaster. So, and then we have also submitted into the communication to the Asia Pacific region our result of experiment. Besides we submit for international and academic publication, we also submit for this standardization body. And then this is our successful experiment in 2020 and also 2022. But with the next, we would like to extend this into the 5G Advanced using artificial intelligence to support the next processing of the telecommunication signal. So this is actually our roadmap the 6G will be in 2030, of which the standard will be 2027 or 2028. And in 2025, we will be having the 5G advance here, which usually we call 5.5G. Even though the quantum is planning according to our plan here is for 2026, but we try to make a more advanced development starting from the next year. And then let me introduce in brief also the framework. This is the approved framework in ITU, and I am very happy that I am also the delegation of Indonesia in ITU, such that we are also having the access to this framework. That in the 6G we have new additional capabilities with this blue color. With this blue color, especially with this project, with this proposal, we are trying to support the AI related capabilities. So the number 3 from the left hand side. And then we are also trying to support the coverage, but for the disaster, I think the coverage will be between 1 kilometer or 2 kilometer, because the height of the base station is not so long. And then everybody can see here that usage scenario of IMT 2030 will be about the integrated sensing and communication. So the new one compared to the 5G is in the green color, but the 6G, the additional in the blue color. Integrated sensing and communication, integrated AI and communications, and also ubiquitous connectivity. So I do hope with this project we can join and work together to welcome the next generation of the 6G. And then let me also introduce this photo. This is, we are invited in Barcelona for the Mobile World Congress in February until March 2023. So at the left hand side, this is the experiment by some vendors for the completely receiver using artificial intelligence, using machine learning, which is called the neural receiver. And then this is very surprising everybody that the machine learning can do the job of the traditional algorithm and can have the same performance with the faster computation compared to the traditional one. And then the right hand side, so this is also the trend in the world about the use of the quantum information, for the quantum cryptography, because of the no cloning algorithm and also the entanglement, which is not available in the classical communications, and the use of the Schrödinger equation for some algorithm. And then this is also our success story up to this point, that we are also invited in Korea to give the development of the classical and quantum communication in 5G Advanced and 6G networks last month in Korea. And also the right hand side, this is the invitation by Vietnam in the Vietnam Innovation Expo. So we also put our product there, which is called PatriotNet. So this is the latest development of this product, and then it is already commercialized in Indonesia with the support of the ASEAN IVO. And then this is the product which we are trying to extend into the 5G Advanced and 6G by replacing some equipment with the new algorithm. And then in brief will be like this: the difference between 5G and 5G Advanced is that the available of the AI there in the radio unit and also core unit and distributed unit, while when we are going to the 6G, we will have the additional channel which is called the quantum channel beside the classical channel shown in the black line. So this is maybe in brief. And then after that, I am also summarize some important algorithm for the quantum radio access network is that the quantum Fourier transform, quantum K-means algorithm, quantum support vector machine, and also the Kroffel algorithm for the database and the fast searching of the database in the future. And then this is also maybe if also possible. So I am also welcome to the idea of everybody. This is our plan to make the quantum key distribution experiment in Bandung. So we are trying to connect Telkom University here and also Bandung Institute of Technology or ITB and also LIPI here. Using the balloon here, so we put the transmitter of quantum key distribution transmitter here, and then we receive in those 3 institutions, and then we try to use those key transmitted using quantum to open the traditional, the message transmitted via the traditional. And if it is successful, and then we put a higher balloon, and then maybe if it is also successful, we are trying to put in the satellite. So this is our proposal. And then related to the quantum machine learning, so we are also expecting that in the future the process and the data will be very big. That's why we need the fast and also smart algorithm. So we also make the difference between classical machine learning, on the top of the left-hand side, with the quantum machine learning that we need additional process we call input encoding and also read out on the measurement. And then we just test a very simple algorithm here, and then we are very surprised that even though with our algorithm, we completely make this successful the mapper using the quantum machine learning. So finally, I would like to conclude this talk. In this talk, we are trying to propose the Patriot Net toward the 5G Advanced and 6G. And then we would like to upgrade with the quantum key distribution, also quantum machine learning. And then we need further help either for the AI or for the classical or AI for the quantum algorithm. And this is some technique to make this is realized. So thank you very much, and I am also welcome to the suggestion and also idea from anybody to make this project is successful. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Okay, thank you. Ladies and gentlemen, you have heard the presentation, and now I would like to open question for the floor. Is there any question? Yes, please.
Yeah, thank you for your presentation. I have a question on the AI part. So in this part of project, do you apply the AI for receiving part only, or for other roles in the receiving chain?
Yeah, this is very good question. Thank you very much. So in this slide, this is for the quantum machine learning for the receiver. This is at the base station for the uplink. For the uplink. But we also need the algorithm, either classical AI algorithm or quantum AI algorithm for the radio access networks, such that it can cover huge number of users, including IoT, not only for the human as user, but also including things. And also, even though we are trying to make a search in the database, I think it will be possible in the future. Thank you.
Also, in your AI, from the diagram, it looks like you have the quantum part and the AI part, right? Mm-hmm. So in the standard, I guess it depends on how you implement, whether you can have information from quantum in AI as well and merge together, right?
Yes, yes, this is also a very good question. So actually, we cannot, in some part we can apply as it is to the quantum, but another part it cannot, because the medium between the classical and the quantum. So at least for the quantum algorithm, we need we already put the sign there, S, X, and also W theta. So that is not available in the classical. And then after that, we need also measurement, which is not available in the classical. But our opinion is like this: if we have something faster in the classical, don't move to quantum. So quantum is only for the thing which is slower in the classical. So we don't replace the classical algorithm in this case. Thank you.
Thank you. Before I invite again to from the floor, I have some question for you, Dr. Khoirul. Mm-hmm. The significant progress of the presentation compared with the completed with previous Patriot Net system is the use of artificial intelligence, 6G, and quantum technology. How this advancement can improve the quality of the previous system?
Yeah, thank you very much, Bu Woro. So yes, okay, let's go back to the previous result of the ASEAN IVO project. So in the previous result, we focus on the 5G. So when we focus on the 5G, we just use the classical algorithm. And then since the technology will be changing, I think our disaster technology should also adapt the new technology and also the new standard. Of course, the standard of the 5G Advanced has not been released. It probably in 2025 or 2026. So once our project is, for example, if our experiment is successful, I am planning to submit to the ITU or 3GPP. But if our result is late compared to the standard, and then we should follow the standard. So that is our algorithm and also our plan and also our technique. So I do hope with that the future disaster technology will be also adopting the newest technology.
Okay, thank you. Any question from the floor? Yes, please.
Thank you, Prof. My question is regarding your proof of concept of Telkom Uni, LIPI, and then you have ITB, right?
Yes.
What kind of frequency will you be using in the POC?
Okay, yeah, this is a very good practical question. So for this experiment, we will be using laser. Yeah, for the transmission of the quantum state. Yeah, so laser we can use either 60 gigahertz or even more than 1 terahertz. Yeah, depending on the laser we are using. But when we are trying to use the low speed, I think we just use the available one in the market, or also the available in the experiment or in the some partner. Actually, we are also expecting the partner from Japan, because Japan is also advanced in the quantum technology. So by doing that, I think we can make also successful project. But even though if everybody is not having such kind of advanced facility, I think we also need your algorithm. So we will come to any new algorithm to develop this. Thank you very much. Yeah.
Okay, there any question?
Very interesting topic. I just want to ask in terms of the budget, the cost that
Yeah.
we are going to implement. If you talk about the context of the Asian country, that I think not many of the country is using 5G, not to mention about 6G. What would be the cost if you were to implement this as compared to the existing disaster management system, for example, the amateur radio or the WPRS system available?
Yeah, this is a very good question, and also very good inspiration actually. So first, we sell this product already. This is already commercialized in the market. We sell in total 800 million rupiah. 800 million rupiah for this. This is until 5G. But for the 6G, for the 5G Advanced and 6G, because the standard is not released yet, I think we are not thinking to sell it within the next 2 or 3 years. But using this project, I'm expecting that we can lead the research on this. Yeah. First, we are in ASEAN. We lead the research on this, and then by using the result, we are trying to minimize the cost. I am also observing that some quantum computer with the 3 quantum bit, the price is around 200 or 300 million rupiah. So I think with the budget of this ASEAN IVO for 2 years is $80,000. I think we can use at least 1 quantum computer to test our error correction and also signal processing. But to make the real 6G, I think we need a more qubit. So I think the budget of ASEAN IVO is not enough. But for the initial research, I think this is very enough. Yeah.
Okay, thank you.
Thank
I have another question for you. If the ecosystem is still using 5G system, do we have to use the previous Patriot Net, or the new proposed system can also be used?
Yeah, this is very good. So this product, this work for 2G, we don't use 3G, 2G, 4G, and 5G. So if your country or if our country is still using 5G, it will be no problem. Yeah. But if you need the budget and we need to submit proposal to ITU or 3GPP, I think it is also a good start to work on this. Yeah.
Yeah, that's not the problem. Okay, still time. There is another question, please.
Can you go back to the QKD?
Yeah, QKD. Yes. This one.
Is there any specific protocols types that you'll be using, or is it a hybrid of everything?
Yeah, very good. So for this experiment, we will use BB84.
Okay.
Yeah, BB84. This is even though this is the old one, but I think this is good enough, and it is also practical.
Okay. Okay.
Yeah. Thank you.
Okay. In terms of QML, is it going to be you're running ML on a quantum machine, or is it going to be a hybrid, or you're injecting quantum into algorithm into ML?
Yeah, so we will use a hybrid like this. So we use the classical computer there, and then we put the sum interface. And we are also, with this project, I am also invite everybody to realize this one. This is the interface to connect the classical computer and quantum computer. So yeah, so for the we are not thinking yet for the radio access network in the outside, for example. Maybe if the data is still small, we don't need a quantum computer yet, but we prepare for the experiment. But if in the future the management or the data is big, I think we will need such kind of computer in every of the radio access network.
At your quantum center, do you have a quantum computer?
I'm sorry, I will cut your question. Maybe you can continue.
Quantum computer, do you have one at your quantum center?
Not yet, but we are trying to have one.
Just let me know when you have one. Right, thank you.
Thank you.
Maybe you can continue outside between you. Thank you very much, Dr. Khoirul, for your presentation this time. And now I invite second presenter from Thailand to deliver the presentation with the topic Unsupervised Crack Segmentation and Detection using Graph Neural Networking Clustering for Disaster Level Evaluation. Yes, the time is yours.
Okay. Hello, everyone. Today, I would like to give the presentation on the research proposal, the unsupervised crack detection and segmentation using the graph neural network clustering for disaster evaluation and infrastructure inspection. My name is Wuttipong Kumwilaisak. I came from the electronics and telecommunication department at the Faculty of the Engineering, King Mongkut University of Technology, Thonburi, Thailand. Okay, let's just talk about the background. Based on the data from the ASEAN Secretariat, the ASEAN regions suffer more than 1,000 natural disasters, which affect 220 million lives for the last decade. As a result, the routine infrastructure inspection, especially cracks appearing on the building or the roads, are very critical to mitigate the outcome of the natural disaster. For example, the Building and Construction Authority of Singapore, they enforce a regulation that every building that have to be inspected every 5 years or 2 to 7 years for the building with a height more than 13 meters and older than 20 years. And this regulation also exists in Thailand. In general, building inspection are conducted by humans, which require intensive resource, including time and budget. For example, in Singapore, you need a facade inspection in the sense that the human workforce have to be in the facade and drop down from the top of the building, and after or the lift from the ground and surrounding around the building for the condition of the building. Fortunately, and you can see that actually it has the concern about the human safety and the budget when you have to inspect the condition of the building or infrastructure. Fortunately, with the advancement of the artificial intelligence and computer vision, we can adopt this technology to reinforce the infrastructure inspection capability. In this research, we will focus on automatic crack inspection since they are obvious indicators of the building conditions. The algorithm design must satisfy the following requirements. The first requirement is that the crack detection and segmentation algorithm should provide accurate crack results. The second one is that the algorithm should be able to apply to various environments, not work well on the specific location. For example, if I apply this algorithm to Thailand, to Singapore, to Indonesia, it should work well, not work well only in the specific location. Third, the algorithm should can be work in real time, okay? Or in other words, it should not require the expensive computing resources. The GPU, only the normal GPU could be able to run this algorithm. Because of in ASEAN country, not every country that have extensive computing resources. Then I would like to review the current state of the art of the crack detection and segmentation algorithm. There are some works in the literature, as I'm showing here, to address the crack detection and segmentation problems. All of them leverage the deep convolutional architectures, which is a type of the artificial intelligence, and the post-processing to achieve the high detection and segmentation performance. However, the AI model, I mean, every model that we are discussing before me, they are trained based on the supervised manner. This means that we must train this model with a label crack image data set. In other words, we need the human annotation to every image in the data set. It's the same like you teach the, I mean, if you think the AI as a baby or toddlers, and you want to teach him or her to know that is this a cat or not cat, this image is cat or not cat, you have to tell her that, okay, this location is cat, this location is not cat. The same thing. With some time, this model may not work well when we deploy them in the unseen scenarios, such as you may face a different crack patterns, you may face a different light condition, and sometimes you may face the irrelevant objects that in the actual scenario when you deploy this algorithm, okay? Therefore, our research introduced a new crack detection and segment method using the unsupervised learning methods. I mean, it means that our performance is not dependent on the training data set. Because of if you use the supervised learning method, when you face a new challenge that is not exist in the data set, your algorithm may break down, it may not work well, okay? Therefore, and this one, and our algorithm can be utilized in unseen scenarios. Our proposed method can divide to be two parts. The first part is used for the crack scanning or the crack detection algorithm, and the second part, after we get the potential crack region or the crack image, we want to segment the crack out to further analyze. Okay, this slide shows the crack detection unsupervised crack detection method. At first, we feed the image to the algorithm to convert the image from the color image to a grayscale image for easier manipulation. Basically, the image can be taken from drone, from the robot that we use instead of the human, and after that we feed and change it to the grayscale image. And then we just apply the edge detection algorithm to capture the possible crack location. This is based upon the hypothesis that normally the crack appear as an edge, and the edge, just simple edge detection can be capture some possible the region inside your image. This algorithm is, you can see as a scanning for the possible region of interest of the crack that appear in the image. Okay. And then after we obtain the edge, we perform some morphological operation to cosmetic the edge. In other words, we use this method to remove some noise of the edge or some object that is not really not belong to crack. Okay. And after that, we perform the contour analysis to identify whether that the edge belong to crack or infrastructure. Because normally, the edge that is totally straight in the horizontal and vertical direction should belong to the infrastructure or the building infrastructure, such as a window or the doors or the building itself. Okay. Based on this algorithm, we can get the region of the image that possible contain the crack. We call it the region of interest or ROI. Then we feed this ROI for segment. This one also unsupervised, no training. No training based on the data set. At first, we feed this one, we first each ROI we first feed these two ROI to the feature extractors. The example of the feature extractor is some kind like the vision transformer or the dyno that provided by Facebook. Note that this feature extractor is a general framework and not specific to crack. We just use them to propose for the only extract the feature. And then after we get the feature, we divide the feature to be smaller patch. Each smaller patch, we're gonna build the graph based on the patch. For example, suppose the feature we divide it to be a 2 by 2 patch. We're gonna have 4 nodes. Each node represents the patch of the feature. And then we compute the correlation between patch. For example, the first patch is similar to the second patch, the first patch similar to the third patch, or the first patch similar to the fourth patch. Then this correlation will serve as the weight for each that link between each node. And then after we build up the graph, we let the graph to learn based on the graph neural network. Graph neural network, actually, it is also another type of the AI, which is very suitable for the information that is you can represent it as a graph. And then, based on the iteration, each node will pass the information together and learn by itself to cluster whether that which one belong to crack or this one belong to the background or etc. Based on this one, we iterate only 10 times, 10 iterations to get the result. And then we combine the ROI together and then form the crack segment. Okay. Let's see the experimental results. The experimental show the performance of our algorithm compared to the supervised. Supervised means that the other algorithm that not ours have to train with the data set. And we test this one with the open data set. For example, like a crack 500 and gaps 384. And you can see that we use the metric like a MIOU, mean intersection over union. The higher the better. The higher the better. And then MAE, mean absolute error. The lower the better. Then F1 score. This one also the test whether that the pixel that you segment, it is correct or not. The higher the better. You can see the result that the unsupervised one, based on the data set, it shows comparative results with the supervised crack detection. I mean that in terms of the MIOU. And then it surpassed in terms of segmentation method, both of the MAE and F1 score. And when we apply our algorithm to the different data set, you can see that it can provide a consistent results. Okay? It means that our algorithm is not dependent on the data set. We can apply all kinds of the environments because it's unsupervised. And the other one, I would like to show you the subjective results. That one is the objective result. This one is show the segmentation results that come from our algorithm. You can see that it has some crack. And then in this image, it's quite difficult in the sense that you have to separate between the infrastructure, such as a window and the crack. And the results show that we can extract the crack quite okay. This one also, our subjective result on the crack segmentation with the unsupervised one. You can see that in some image, it has a different light condition. Okay? And in this case, the segment crack is quite okay in terms of this one. Okay. Then this one is a subjective result. Then let's talk about the contribution. Our contribution on this research in terms of scientific and technological perspective is that our algorithm proposed a new crack detection and segmentation that can be utilized in the building inspection. And after we get the crack, we can use that one to evaluate whether how severe the crack, what is the condition of the building, so that we can take the proactive measure to prevent the natural disaster, or even when the natural disaster happens, we can feed this information to the disaster strategies to make decision whether that we should evacuate or something else. In terms of the society perspective, like I told you, that we can use this one to provide the proactive measure to prevent the disaster outcome of the natural disaster. In terms of the collaborative perspective, we open to collaborate among the ASEAN because of in ASEAN, in every country in ASEAN, together with Japan, we face similar problems in terms of the natural disaster. For example, the earthquake in Indonesia, and have the tsunami also the affect Thailand, and the earthquake in Myanmar also the affect the Thailand. And conclusion, in the future works, we want to improve the unsupervised crack. We want to improve the crack detection algorithm to give a better result in terms of the detection, because of we want to get a better result and can be used. Okay, that's all.
Okay, thank you very much. Now it's time to invite the question from the floor, please.
Please.
Yes, please.
Thank you. Well, I'm not a civil engineer, but I have a lot of friends in civil engineering, you know. I want to get some more, because being not a civil engineer, I cannot grasp the whole idea about the detection system. But
okay,
in the crack, you have many type of cracks. You have the crack in the metal, structure, or cracks in the wall, or whatever it is you see. And the crack can be caused by many types, because of the water. The water becomes has a lot of salt, for example, and so on and so on, because of tsunami and movement of the ground and so on. Now, how do you detect the differences of those type of cracks, and then say, okay, this crack, the most significant crack is in the metal structure, and not in the other part. That is how you can definitely say, okay, this is the crack is in this part, and this has to be improved. This has to be overcome, the crack, because the crack is in that particular part, because you are using what kind of depending on what kind of sensor you are using, and what kind of detection system you are using.
Okay. Normally the sensor that we use is just taking the image taking the image outside, and after that we feed to the algorithm to detect the crack. I mean that, for example, the crack is in the. I mean that imagine that we want to use a drone to fly around, and after that just take the picture, and then the picture we feed it to the unsupervised one to detect the region of interest. I understand that you are asking that whether that can we differentiate between the crack in the metal and the crack in the concrete. You mean that one? Is it your question? Basically, it doesn't matter. I mean that whatever that we get the information that and it has a shape like a crack, we can identify the region and extract it out anyway. It doesn't matter. But for the crack classification that you asked, there are a lot of the type of the crack. I realize that, and I mean that the unsupervised. I'm trying to explain in this case is that the unsupervised way is this good for the crack detection and crack segmentation, but for the crack classification, I may admit that we may have to go back to the supervised one. It means that we have to train the AI to learn a lot of type of the crack. But before that one, you need to detect and segment it first to further processing. Am I answer you the question? Okay.
So if the crack is inside the wall?
No, if inside the wall, we cannot.
All right.
Because of our algorithm, it's just a surrounding outside and take the picture. For example, like I told you in Singapore, I got this problem from the Panasonic Singapore. Singapore, they have, like I told you, every 7 years they have to have the building inspection, and normally they use a human to go to take a look of whether it has a crack on the building or not. And then it's pretty hard when you have to deal with a very very tall building. That's why they want to use a drone and the robust algorithm that after you take a picture, you send it to the server, and after that server can help the human to detect crack and segment the crack.
Still have time? You have another question? Please make it short.
Yeah, so quick question. I think reiterating Dr. Ashwin, I may have misunderstood his question as well. I think he meant, actually I thought my question is actually, can you differentiate between cosmetic cracks and structural cracks?
Cosmetic crack?
Yeah.
Cosmetic crack is mean, what is the meaning of cosmetic crack?
The structure is sound, still steady. It's just the,
I see.
Yeah.
Let me answer this question. The cosmetic crack, I mean that actually is not crack, right? Yeah. Basically, we have, I mean that normally, if it is a cosmetic crack, in your definition, it's going to have something like a structure that is very straight. For example, in a horizontal way, or in a vertical way, or in some angle. In this case, we're going to filter that region out. And then we're gonna get the region of the crack that is not that one is in a contour analysis, and after that we feed that one to extract the crack. You understand what I mean, right? One more thing is that I would say that the algorithm, especially in the detection, is gonna my algorithm, our algorithm is gonna be break down when when you have the drone, and after that you take a picture from very far, what you're gonna have is that you're gonna have a lot of the building, and crack is a very small thing. That one is break down. That's why that I would like to attack this kind of the problem, which is a very, very serious problem in this case.
Okay, I think you may continue after this session.
But I would like to say one thing that I would like to thank you, the ASEAN IVO and the NICT to sponsor my traveling and accommodation. Okay, thank you very much. And if you have a question, please come and discuss to me. I open for collaborations.
Yeah.
Okay.
Thank you very much, Professor Wuttipong.